Be hard to get flight deck cameras of meal prep, people eating meal.
I concur, John. And I got another item whenever you have a minute on the IMU line coming up.
Okay, what you want to do?
Okay, basically we want to delete that alignment at 1049 and take the starts of opportunity.
Delete it? Say again, over?
Negative, just delete.
What did you say, over?
Roger, we just want to delete the maneuver to the next IMU alignment at 1049. And instead, we want you to take the stars of opportunity that are already selected, number 36 and number 59.
Houston, Columbia, over.
Roger, John, loud and clear. Did you copy my message on the IMU alignment?
Yes, do you want me to stay at the present attitude and go to DAP A, or do you want me to go to the other attitude to hold the timeline and then go back to, what do you want me to do, over?
Okay, here's what I want you to do. Delete the maneuver scheduled at 1049. Pick the stars of opportunity, number 36 and 59. Select DAP A1 at 1049 as scheduled. And then jump over to the maneuver at 1116 as scheduled.
Okay, I'll do it.
Space Lab Marshal, we got the loop back now, and Bob, for your information, it looks like we had another excellent, successful 22 run, and thank you for your effort.
No, thank you until we get the phone back.
Say again, Bob?
Just don't thank me until we get the film back. Space Lab, PS2 here for the 300 people.
Listening, Bob, or Byron.
Okay, very good. We're standing by, Chuck. We've done what they asked so far. I've read off the rest of the instructions to Ulf, and we'll just be standing by to see whether they want us to do some more or put the connectors back on and whatever.
Byron, this is 300 ops. Byron,
Go ahead, 300 ops. Go ahead, Jürgen.
can you enter, please, DTA 056174 and enter?
Okay, we did that, and I'm reading 004 up. It just changed. Hold on. Went to 015300. It's 01. Keeps jumping around.
Okay, thank you.
It's 003300. 025300. 012.
Byron, can you try to change the connectors, interchange the connectors J5 and J7? They have a different code. For that, you have to disassemble. Just stand by.
Jürgen, this is Ulf speaking.
Go ahead.
Okay, Byron is at the end of his shift. If you don't mind, then I will take over from him.
Okay, Ulf, that's Jürgen. Ulf, how do you read?
Loud and clear.
Okay, we have a new step now. I want to connect the MHF connector directly to the power supply. That means you have to interchange P5 and P7. but unfortunately they have another code. You have to disassemble connector P5, remove the shell.
Go ahead.
Remove the shell of this connector and connect to P7.
Okay, for clarification, disassemble P5, remove the shell of P5.
Okay, stand by, Justice. Ulf, stand by. Ulf?
Yeah, go ahead.
Connect P5 to J5 to P7. P7 is the connector, the socket on the power supply. And you have to connect the harness P5, J5 to P7.
Okay, once again, you want to connect connector P5 to the jacket, correction, P7, connector P7 to the jacket J5. Is that correct?
The other way. J5 to P7.
J5 to P7. Now, what is the connector? Is J the connector or is P the connector?
J is a connector on the harness, and P is the receptacle.
P is the receptacle and J is the connector. Okay.
Yeah.
Again, I disagree. If I look down into the MSDR, then I see a connector called P5 and another one called second P7.
That's
so
correct.
P stands for plug,
Yeah.
and P seems to be the connector.
Yeah. P5 to J7 at the power supply.
Okay, we understand. Connector P5 to receptacle J7.
That's correct.
Okay, we'll work on that.
But Ulf, the problem is that there is another code. You have first to disassemble the connector.
Okay, so I disassemble P5 in order to connect that.
That's correct.
Okay, Jürgen, before we start to disassemble the connector, I suggest Byron suggests to switch off the MHF IHF heater.
Yes.
Okay, that's done.
Columbia, Houston on air to ground 1.
Go ahead, over.
Roger, John, we'd like you to check your future option, yaw, selected for 1116.
Okay, thank you, Houston. And if you can give me those kind of changes a little further ahead of time, I probably won't make so many mistakes, over.
Roger, John, we understand. Sorry about that.
POCC, Space Lab.
Go ahead, Bob.
Yeah, do you want both TVC1 and TVC2 up for this new TV15?
Stand by.
Roger.
TVC1, Bob.
Okay, thank you.
Okay, and Bob, we're ready to go on with the daily planning if you got a PCAP.
Okay, I'm moving over that way. Okay, where were you? CC, go ahead.
Stand by, Bob. Okay, we're looking at hour 13.
Okay, hour 13.
Okay, you want to make a couple of minor changes over in the notes column relative to the 22 run. The targets are 57.10 plus or minus 0.5.
Copy that.
Also, minus 6.40 plus or minus 0.5.
I got that.
The orbiter z-axis slightly down a couple of lines, 86.08.
Okay, 86.08.
That's affirm, and negative 21.94.
Okay, got that.
At 13 plus 20, you have minimum ECAS 7.38.
Okay.
Okay,
Copy that.
Roger. And the 201 run at 13 plus 25 is now oscillopsia on PS1.
Roger, I understand that. And then both of us for the subjective vertical.
Stand by. We'll get you an answer on that one, Bob. In the meantime, we can go to page 14.
Okay. Yeah, I need, and all time downlinks. We don't have to worry about switch.
Breaking up, Bob. Stand by until we get a good downlink.
Hey, I'm on hour 14.
Hour 14, that's affirmative.
Ready?
Okay, minimum ECAS 7.38.
Got it.
The 201 activity can continue until 14.35.
Okay, but somewhere there I got to get out to do the 22, right?
That's affirmative, and as a matter of fact, your side continues back to back with that 22 run at 14 plus 30.
Okay, so that means Ulf will do the cleanup and stow, I guess.
That's correct, you're right. We got a change on target F20, right ascension and declination on the notes column.
Go ahead.
That's now plus or minus 2.0 for both the RA and the deck.
Got it.
And we're coming up on LOS. We'll get the rest of the
Whether or
weather.
not, these are just punches of whether or not Faust is piggybacking, right?
I'm not sure on that one, Bob. We'll have to get back.
Sense of powering them on and off
Space Lab Marshall through Hawaii for 1 minute. And Ulf, if you're running 326, Mike Haynes is on the line and has a change for you.
Perhaps.
Good morning, Ulf. Speaking on behalf of Madame Rodot, she would like first to confirm that you're using the low viscosity, that is 5 centistokes fluid. Is that correct? Over.
Oh, we have already the 5 centistokes installed here. That is too late now, Mike.
Okay, Ulf, that's fine. Then the only other instruction from her is, would you limit the amplitude to an absolute maximum of 0.45 millimeters. In fact, in the earlier run at 0.15, we observed quite violent excitation, so you should be very careful on the amplitude. Over.
Want to do it with the same amplitude, or what was that?
The remark concerned the amplitude of the excitation of the 20 millimeter sphere, and Madame Rodot's advice is to limit this to 0.45 millimeters. In fact, in the earlier run, 0.15 produced an almost uncontrolled oscillation. Do you read? Over?
But 0.45 is larger than 0.15.
That is correct. Madame Rodot's advice is that this should be the absolute maximum, but my advice, if I might interpose it, would be to be very cautious with the drop. Okay?
Okay, thank you.
Space Lab Marshall AOS for about 56 minutes through Tetris.
Okay, Space Lab, we're with you.
Okay, Bob, are you aware whether Ulf was able to get the reconnections made on the 300 power supply? The 300 ops guys are looking at their data, and they're anxious to know what they're looking at.
Badly broken and unreadable. Try again in a couple minutes.
Copy. Space Lab Marshal, we ought to be back with you here, Bob. Just a note to ignore any air messages for experiment 20 sometime around 11 plus 5, 6. They're going to be commanding to... ECAS is going to try to command the passive package, and since it's not connected, they're going to get some error messages.
Okay, I understand. And if you had anything else to say to us when you first came up, we didn't copy it because you were so broken.
Okay, the question, Bob, was really for Ulf, but we didn't want to bother him if you knew the answer, and that was whether he was able to get the connections reconnected in the power supply.
No, the question really came as to how to take the inner plug out of the shell. It looks like the sort of a rubber plastic interior mold that the pins fit into that appears to be glued to the shell. It's not clear how to get that out of the shell.
Okay, we copy that, and
this is Ulf speaking.
Try to get back. Loud and clear, Ulf.
Okay, there is a metal part, like a ring, which goes around a brown type of isolator, which in a way contains all the pins. And the real question is, where are the wires connected to the pins? Is that behind the brown part or is that inside? That brown isolator is glued into the metal shell, and I'm not sure whether it is a good idea to, let's say, dismantle the cable behind the brown part. But that is the only option we have because the brown isolator is glued in the shell.
We copy, Ulf, stand by.
Sometime, Chuck, we need to talk to you guys about the new 201 procedure, make sure we understand it.
Copy. Space Lab Marshal for Bob.
Ed.
Okay, Bob, if you have time while 22 is running, 300 ops would like you to reconnect the MHF connector to P5, which is the original configuration, and then they'll look at what they got on the ground. And in the meantime, for Ulf, John Pede is here representing Madame Rodot if you have any questions on 326.
Okay, I have two things. It is a bad idea that we are doing two things at the same time at the same spot here. I'm standing right in front of the MSDR, and I think as soon as I'm done here, we'll resume the connector work. And the second thing is I have roughly a 18 millimeter sphere here, and I determined one resonance as being 2 hertz, and I'm now ready to film the decay of that free oscillation.
Copy, Ulf. We concur.
Space Lab, this is 326 PI. For Ulf.
Go ahead, Mike.
Ici parle Madame Rodot et je t'écoute. Correction, it's not John Paddy, it's Mike Haynes. We're getting data on the VDU. We've got you at the moment showing an oscillation frequency of 0 and an amplitude of 0.1. I copied your notion of going on studying the decay, and this is fine. Thank you very much indeed.
Okay. And CLCC Space Up.
Go ahead, Bob.
Yeah, I've been checking in the 22 flight data file and can find no reference to it, but I keep being bothered by a suspicion that we were supposed to have the aft windows of the orbiter closed for this, but I can find no mention of it in the flight data file. Can you verify one way or the other for that for us?
Stand by. We'll get right back to you.
for your record, I took 200 frames for the first decay.
I read 200 frames. Thank you, Alf.
I'm now trying to make the sphere a little larger.
Okay, I would guess that this is the intention of Madame Radeau, because there is a slight inconsistency in that going on to step 8 at this point, you're dealing with a 40mm sphere. I guess that she wants you to make it as big as it would be safe to pursue.
I don't read you very clearly, but I understand that the 40mm sphere is an impossible thing because it will overspill due to a too big contact angle.
Yes, we feel the same thing, so I think you should proceed with discretion and go to the largest sphere which you think is safe. Over.
I'll do that.
Space Lab Marshal for Bob. Answer to your question on the window, Bob. It's a Faust requirement, and they would like to have the aft window on Space Lab curtained since they're running jointly with this 22 run.
The aft viewport on Space Lab.
Affirm.
That's close. Mike, note that the amplitude used for this last resonance was only 0.2 millimeters.
Say again, Ulf, I didn't get all of that.
Amplitude for the excitation was 0.12 millimeters. 0.12.
I copy 0.1 at 2.
0.12.
Okay, Ulf, can you please give me some estimate of the size of the sphere which you have at present? Is it still 18 millimeters, or have you increased its volume? Over.
Yeah, I'm now at roughly 30, maybe 27, 28 millimeter diameter.
Okay, I suppose that's as far as it's safe to go. Over.
Without oscillation, it looks safe.
Space Lab for Ulf, 326 PI.
Mike, go ahead.
Ulf, I'm following on the VDU what you're doing, and looking also at the clock, and I think we only have another 5 minutes left for this run. So if it's possible for you to proceed to the dashpot part of the experiment, I think that this would be appreciated by Madame Radeau. Over.
Okay, I will film that one here. And I will try to get it in touch with the plunger.
Okay, that's great. Good luck.
Thank you.
And Space Lab for Bob, for your information, experiment 22 says that looks like they got their exposures and they're on target.
This is even one of my favorite targets. Right. I'm all done, so I don't need that tap again. Thank you. POCC here, but we still need to talk to you about the 201 run.
Roger. Space Lab Marshal for Bob.
How'd you go?
Okay, Bob, I've got a little bit of review on this oscillopsia run. I can either go through that now, or if you've got specific questions, we'll try and answer them.
Let me just ask you a couple of specific questions here. One, understand that the PS is the subject and not the MS. And question is, do you want us to use the long EOG cables? My recollection was on day one we decided that the long EOG cables were not doing as well as they should and the short ones were better. That's the first question. Second question is, what's the destination of the TV? Is it going down real time and we don't have to worry about handling it? And the third question is, I gather we're doing, in the standing position, we're doing both the yaw and rolling oscillopsia as before. We're also doing the Z oscillopsia. And then in addition, we're doing oscillopsia with pitch, with the eyes open, and then oscillopsia, with, which I don't understand, with eyes closed in pitch and eyes closed in yaw. Is that correct?
Stand by. Space Lab for Bob. Answer to the TV destination. It's going to the orbiter recorder, and we will configure it. You control it.
I understand you will configure and control it, right? But I'll have to tell John to turn on the VTR then.
That's affirmative. We will configure it, and you can control it with a call to John.
Okay. In fact, do you want TV during the whole session, both oscillopsia and vertical, subjective vertical?
Stand by. You got the whole tape, Bob.
Okay.
That's from the DMC, and we'll get a request from the 201 folks on it too, but DMC says you get the whole tape if you need it. Space Lab Marshal for Bob.
Where'd you go?
Okay, We're going to try and explain your question here, Bob. What we're doing is adding to the original procedure a number of steps which involve oscillopsia during pitch. We want you to close your eyes and do pitch movements, and then close your eyes and do yaw movements. This will be done with the helmet as per the original. It's just an addition to it. Then we want you to repeat those 3 steps with the helmet. That's just doing it a second time. Then we want you to doff the helmet, holding it using the long EOG cable, and repeat that entire protocol.
Okay, but does that mean you want us to use a long EOG cable for the entire thing?
That's affirmative.
Change out EOG cables then. Okay. Question, you said we're going to do the regular procedure, and then in addition to that, we're going to do oscillopsia with pitch. And I assume that the new step 5.3.1 is with pitch with eyes open. And then 5.3.2 is pitch with eyes closed, and 5.3.3 is yaw with eyes closed, correct?
That's affirmative.
But there's 3 extra steps to it.
Affirm.
And that's done, each one of those steps is done once with the helmet and once without the helmet.
That's correct.
Okay, then is there only a single subject for the subjective vertical or 2 subjects?
2 subjects if you can get it done in time.
Okay, 2 subjects, okay. And that means donning the helmet again. I notice we don't start that until 1410. My guess would be that we would be done the oscillopsia long before 1410. Is there any particular reason for specifying 1410?
Stand by. Space Lab Marshal for Bob. No particular reason for the 1410. You can do those in sequence as you finish one and start the other. And a clarification, just to make sure you understand, we'd like you to do all of the steps twice with the helmet on and with the helmet off.
Okay, so the oscillopsia should be done twice. Is that correct?
That's correct.
Right. And also, question, I would assume that for subjective vertical they want the EMIR, but EMIR disappears about 1412.
That's not crucial.
And EMIR is not crucial. Okay.
And Bob, if you don't quite get to the luminous line experiment before you run out of time, that's okay. We'll just try and catch that later. And you can ignore 01 error messages ISO's commanding.
Okay, but we'll both put on electrodes just in case we get to that far.
Copy.
Marshal, this is PS1.
Loud and clear, off.
Okay, for your information, or for Madame Rodot's information, I'm finishing up here. Bob did the gas sample, and the status as follows. I was able to fill the second time a small sphere, roughly 20 millimeters diameter, with 5 centistokes oil, and the same for a 30 millimeter sphere, determine the resonance frequencies. And when I tried to attach the larger sphere, the 30 millimeter sphere, to the plunger, the oil spilled over the edge of the small support plate. So that was unfortunately not possible.
Copy that. And does that imply that you had success with the smaller sphere, Ulf?
Again, Chuck?
We copy you had an oil spill with the 30 millimeter sphere when you tried to attach the plunger, but the 20 millimeter sphere worked okay.
Yeah, I did the 20 without plunger and the 30 without plunger. And then I was trying to connect the 30mm sphere to the plunger to do both with plunger. But the same moment when the plunger hits the surface of the sphere, that causes a kind of wave to the surface, and the contact angle at the support plate exceeds the stability limit and it spills over. That is just due to this excitation when the whole thing gets in contact with the plunger.
Roger, copy that.
Space Lab for all 326 PI.
By the way, I think I have that on film when that whole thing got in contact with the plunger, so you can analyze it post-mission.
Space Lab for all 326 PI. Yes, I understood all that very clearly, and that's marvelous. We appreciate all your efforts. Thank you very much. But one general question of interest to all the PIs. Did you observe any effects of G-jitter on the shape of the drop? Did you observe any adventitious or spurious oscillations? Over.
Mike, I have really trouble to read you. I'm not sure whether you have a bad microphone. Maybe Chuck Lewis repeats the same thing.
I'll ask him. Space Lab for Ulf, Mike Haynes once more. Let me try a second time. The question was whether you observed any effects of G-jitter on the drop. Were there any spurious oscillations which you did not deliberately excite? Over.
The problem here is, Mike, the plunger is not really symmetrical. It's not aligned with the axis. And that is probably because the damping oil in the dashpot pulls it to one side. It's impossible to keep it right on the axis. And when that plunger hits the sphere, the whole column is asymmetrical for a short period of time, and the contact angle on one side of the support plate gets very large because there's a surface wave running along the sphere, and that exceeds the stability limit of the surface angle. Of the contact angle, sorry.
Yes, understood. The situation is that the plunger is off axis, and still one question of interest to us all. When the drop was free and untethered and not being moved, did you observe any effects of G-jitter, please? Over.
I don't read you, Mike. I'm sorry.
He's asking Ulf if you can read me if you saw any effects of G-jitter, golf jitter.
Negative.
Okay, thank you.
Copy.
By the way, the G cleanliness is extremely good here. We don't notice anything. With all the columns we had in the fluid physics module so far, there is absolutely no effect of thruster firings.
Copy, Ulf. Thank you.
Space Lab for Ulf 326. I have a request to ask you to reconnect the MHF connector. Over.
CC Space Lab.
Go ahead.
Okay, starting to do the electrodes here. I thought I might tell the 201 folks, we only have 22 electrodes remaining. I don't know whether we're doing 3 more days of this or just this day and another day, in terms of whether you want to electrode both of us.
Okay, we'll try and get an answer on that, Bob. While we're waiting, just a point of information. If you could turn on the TVC-1 camera before we come up on the Hawaii pass at 13:05, we'd sure like to watch you doing the 22 ops with the SAL through that pass, and then you can turn it off after the pass.
Okay.
Okay, Bob, on the electrode question, they only want the electrodes on PS1 because they don't need them for the luminous line.
Okay. Marshal Off, this is PS1.
Loud and clear, Ulf.
Okay, Chuck, whilst I'm electroding myself, what is the status of the connector business of the MSTR?
Stand by.
Yes.
Let me give you one more input. We might be able to build a jumper cable, but you have to go in touch with the orbiter in-flight maintenance people to see what sort of connectors we have.
Only,
Inside and so on.
Wolf, only reconnect MHF to the power supply, the old configuration, not
Okay.
IHF.
Okay, P5 to J5 and P7 to J7.
Negative. Not P7, just P5.
P5 to J5.
That's
Okay.
correct. Wolf,
And
then switch on MHF at the central console for a short time, and then switch off.
Okay, but stand by, we are not ready to do it right now. I call you as soon as I'm ready for that.
Okay, thank you.
Space Lab Marshal, LOS in 2 minutes. We'll see you again through Hawaii at 13:05, and wish you good luck with the 22 run upcoming. We'll be looking for TV.
Okay? TV's on.
HRM tab, you'll be able to see the execute and tell where they took it. Okay. And that does about as much as reloading would do. That causes it to go through and reload. It actually reloads from this little loaded buffer there and re-executes everything. Yeah. Try that, and if that doesn't work, reload 6. Okay. And then try it again. Okay.
Have you heard anything more about when we're supposed to start doing this?
Yeah, there's you just gave me some notes and I wrote it down here. You ought to write this in your handover spot in the log. Okay, Ray, you still there? Sorry, I got pulled off.
Yeah, I'm here.
Yeah, the words on the power cycle. If the pallet freon loop temp is greater than 72 or RAL 21 starts experiencing skips, we will cycle the VFI. Okay, that's the criteria, and the purpose is to reduce pallet freon loop temps.
Okay, so
It's leave it in the log for people. We're not doing it until either one of those conditions happens. They wanted to have everything ready.
okay.
And I'll go see if we make some targets and this thing. Make a few copies of it. And
Tell us if that.
Info Spaniel.
go ahead, Stan.
Hey Bob, I'm about to do a handover briefing for the hospital that any words you'd like to pass on to them. As far as I know, the ship got the problem with the power amplifier. Everything else is about to start normal.
That's about it. I guess the only thing I'd mention is we still are seeing funnies in the high rate mux that we really can't explain. Overflows when we don't think there should be overflows, etc. We've just got a general anomaly open that says we're seeing overflows at oddball times, and we couldn't dump the high data rate recorder very well at 32 megabits, but it's working fine at 24. And that's not really a new anomaly, it's something that's been going on for a long time.
Okay.
But just might mention that. That's the only thing I believe we got.
Okay.
And the talk of cycling the VFI to keep the pallet freon loop temps down.
Okay. Thank you.
Okay? Hey, Jay? He's off, Steve. Okay.
Space Lab, Marshall Ops, AOS Hawaii for 7 minutes.
I see you, Chuck, loud and clear. For your information, we are extending 22, and we have the J5 connector connected, the P5 connector connected to J5.
Okay, Ulf, we copy that. Thank you very much, and we're looking for some TV.
Okay, if I understand Jürgen correct, he wants me to switch on the IHF quickly and switch it off again. Or MHF, whatever it is. The selector switch is now at MHF. But before I take action, I'd like to get that confirmed.
MHF, Ulf, MHF.
MHF, and he wants to get it on, right?
And also the heater power on the power supply, Ulf.
Okay, MHF is on at the power supply.
Okay, Ulf,
The
can you...
lamps on. Wait a minute, we have the lamps on in the mirror aging facility here. I better switch it quickly off, it is successful. We can use it. Great.
Hey, Ulf, great. This is Wilbur. Great.
I switched the power supply off because I think we have to patch the software and start from scratch.
That's terrific, Ulf, and be advised we're getting a good view on TV of Bob at the airlock, too.
Oh, fantastic, hey.
And Space Lab, be advised, we see the camera extended out above Space Lab on the outside camera view. Looks terrific.
CC, you want us to start this one the same 30 seconds early we've been doing?
Stand by.
It's only 6 seconds after sunset, according to the table.
Negative, Bob. 0511 as per PCAP.
Okay, I thought somewhere somebody told me to start at 30 seconds early all the time.
No, that was just for the previous one. This one, they're happy with what you got down there.
But that made sense to me, too. Hey, Marshal Ops, as you might see on the telemetry, the 22 is working really great.
We copied, Ulf.
We have the shutter open, we are taking the first frame here.
And the ground data looks okay, Ulf.
Yeah, looks great.
And Space Lab Marshal Ops for Ulf, if you could read off the filter and exposure times on your display. We don't have it on the ground here. Over.
Okay, we are on the grading. It's filter 4. Exposure time is 500 seconds. And we are standing by for the shutter to open.
Roger, copied. Grading and 500. Over.
The grading moves in. It's in. The shutter opens. We are in business. Counting down. 499.
Space Lab, we're going LOS. We'll see you at 1320.
Okay. You read, Marshal?
Still read, Ulf, but we should be LOS. Space Lab Marshal through TDRS for 52 minutes.
We are ready to remove VCAT. There's one thing, we had RAL 14 skip message, and consequently the MSDR shows an SIU data fault site.
Copy off, and we'll get back with you.
Okay.
Space Lab, Marshal Ops for Ulf. We have 2 minutes before starting 201, therefore I would like to brief you for a short procedure on the MHF, over.
Okay, go ahead.
Okay, what we need is an open 174362.
Is that only one, or is that, hold it, Womo, is it one open or more than one?
It's only one open and one close.
Okay, I do it in real time. Open.
1743
7.
4362. Read back the whole number.
Okay, I have open 1743, and I missed the last part. Was it again 43?
Negative 62. And read back the whole number.
Okay, open 174362.
That's an affirmative.
Okay, that has been ended.
And then close with 6 zeros. 6 balls, over.
Close 60, go ahead.
Okay, and Ulf, then you can continue with starch MHF, enter. And if time continues...
Move on, hold it. Hold it. Your instruction wasn't really clear. It was close and then 0, 0, 0, 0, 0, 0. Is that correct?
That is correct.
That's complete.
And then Ulf, start MHF, enter.
Okay, start MHF, enter. That's complete. We have an MHF stoplight on. I'll display it. Stop idea is 302.
We copied, Ulf. And,
Marshal Ops,
yes, Ulf?
what the stop 302 says is that the power switches are not set.
That's right, you...
And that is true. I switched. Go ahead.
Make sure that you look at page F400-12 and step 1.3 to 1.8 and then get on with 201.
Okay, I'm at F400-12. Now go ahead.
Okay, Ulf, and perform step 1.3 through 1.8. Over.
1.3 to 1.8. Okay, we'll do that. Okay, complete.
Okay, Ulf, thank you, and please continue 201.
Okay, we'll do that. Okay, no problem. We're done, thank you. Kind of is. POCC Space Lab, we're delaying here a minute because we've lost the accelerometer. We had it out here a few minutes ago.
Copy.
Okay, POCC, the lost is found.
That's great, Bob, and we're looking in the PCAP, see if we can find you some more time.
Again about the PCAP?
We're looking for a little more time for you, Bob.
Okay. Hiding behind the lyo canisters, would you believe that?
Sure. Space Lab Marshal, Bob, you can continue up to 14 plus 30 when you have to start the 22 run, and Ulf has lots of time after that for stowage.
Okay.
Space Lab Marshal, we have Amir. Space Lab Marshal, could you tell us the Amir settings, please?
The setting is Bravo 5 for the EMIR.
Copy, Bravo 5. We'd like you to Alpha 5, please, Alpha 5. And the accelerometer signals look good.
Okay, you see accelerometer okay?
That's affirmed.
Give me Y. Here comes Z. Okay, and all we're going to look at today is roll on joystick, so if you're watching for a joystick rotation, it's coming at you.
Roger, and roll is okay.
Okay, and we'll give you an EOG balance, okay? You got calibrate cross balance? Okay, all right. Staying ground. You hearing Ulf?
We're getting good Amir signal now, Bob.
You're hearing his voice, correct?
That's negative. Can you relay?
Okay, stand by. I'll try and set that up again. He's kind of... Hey, how do you hear Ulf now?
Negative.
He reads you, COCC. As far as I can... Try again. Ocelot, this is STS-9. 123. How do you read?
Now I read you loud and clear, Ulf. Go ahead.
Hey, fantastic. How are you?
Just great.
Okay, was the EOG calibration satisfactory for you?
We need one more calibration on the EOG, Bob, if you would, please.
Okay, one more calibration, please. Okay. Santa. Santa. Right. Santa. Left. Santa. Up. Santa. Down. Santa.
And could we have an up, down again, please?
Santa. Up. Santa. Down. Santa.
Okay, that's fine.
Okay. That means that the long EOG is also working today.
That's affirmed.
Okay. That's great. Okay, I'm giving you oscillops here. Roll, we started roll, right? Any particular frequency?
Yeah, 1 hertz, Bob.
turn on the orbit of VTR? I can hear that. No problem. I think it's payload 1. Stand by. Go ahead, put payload 1 on. All right, thank you.
Space Lab Marshal for Bob.
Payload 1's what we want. Order the second check. Go ahead, POCC.
Bob, was that first pass run or roll or yaw, please?
They were starting out with yaw, and we're restarting because I didn't have the orbit of VTR on. Okay, we're ready to start now. Go ahead, roll. Would you turn on the orbit of VTR? I can hear that. No problem. I think it's payload 1. Stand by. Go ahead, put payload 1 on. Thank you.
Space Lab Marshal for Bob.
Payload 1's what we want. Order the second check. Go ahead, POCC.
Bob, was that first pass run or roll or yaw, please?
They were starting out with yaw, and we're restarting because I didn't have the orbit of VTR on. Okay, we're ready to start now. Go ahead, roll. Okay, now we go to eyes closed pitch. Now we go to yaw, eyes closed. Okay, POCC, that completes the first half. We'll go back and repeat the same thing before we take the helmet off.
Yeah, we'd like a balance, please.
How's the Emir?
Emir looks great, Ulf, and we'd like a balance at first opportunity, please.
Okay, Thunder. Calibration or balance? Full calibration or balance, PLCC?
Just a balance, Bob.
That's all I have. Okay. Now we go to roll. There's no way to take past the seven. Now we go to Z. Any reports of oscillopsia? Oh, okay. Now we go. Only yours, I go chop, full speed. Full speed, okay, very fast, all right. Now we'll go to pitch, eyes open. Eyes open. Wait a minute, I have the eyes open. Yeah, but then we'll do pitch, eyes closed after. Okay, pitch. If I go really fast, I can make it a little. That is how good. That way, no. There's no interrupt anymore. No wonder if we don't get it fast, we may get it. Okay, eyes closed, pitch. Now we'll do eyes closed, yaw. Okay, I believe that completes the helmet on oscillopsia, ground.
Okay, Bob, that looks good. And would you ask Ulf to quantify the oscillopsia that he saw, whether it was one target width or less?
Okay, if I go in yaw as fast as possible, that is to say, let's say 90-degree swing, then I can make oscillopsia in the order of one line width of the clock. You copy?
Copy, Ulf. And did you use the accelerometer on the bite stick?
I have the accelerometer attached to the bite foot. Yeah.
Copy, thank you.
You copy that, POCC?
Roger, understand.
All right, now we'll take... Go ahead, POCC.
Just confirming, Bob. We copied that.
Okay, now we take the helmet off, we'll hold it, and do it against the back wall.
And Space Lab, Marshall?
Go ahead.
Wonder if we could have a final calibration with the helmet, Bob.
You that for this calibration, the helmet's been off already. We're putting it back on.
Okay.
Centered. Right.
Center. Right. Center. Up. Center. Up. Center. On. Center. Complete. How's that?
Okay, ground.
Looks fine, thank you.
Is it okay? I have to use your sound.
Okay.
open against your calibration first. All right. Here comes you got the calibration ground? Could we have another one, Bob? Yeah, CC, you get the calibration? That's negative. We couldn't hear off. Could we have it again, please? Alright, center and balance. Right. Center. Left. Center. Up. Center. Down. Center. Okay, Space Lab, we're happy with that. We're going with the yaw. Standing open. Little off-lops, if you find some, slow it down to the threshold and mark the threshold. Okay, there's threshold now. Space Lab, Marshall, we have beautiful signals. Now we go on to roll off-lops, yeah. No off-lops yet? Oh, can you get a threshold? Okay, threshold. Okay, now we go to Z-axis. Okay, nothing in Z-axis, all right? We now go to pitch. Eyes open. Okay, a little here comes threshold. Okay, now we go to eyes closed and pitch. Now eyes closed and yaw. Okay, enough of that. Now we'll go back and repeat the whole thing. Open yaw. Threshold. Okay, roll. Threshold. Threshold and yaw, and roll. Okay, now comes Z. Okay, nothing in Z. All right, now comes pitch. Okay, here comes threshold. Okay, now comes eyes closed pitch. Eyes closed yaw. Okay, that's enough. Go CC Space Lab, you still with us? Sure are, Bob. The data on the ground is beautiful. Okay, and you can see he's a little bit more sensitive to oscillopsia, I guess, than I used to be anyway.
Okay, and looks
now
like... Looks like we're way ahead of schedule. If you guys feel up to it, another run through would be icing on the cake.
Do you want to do that, or you want to worry about the vertical reference?
What's anything?
POCC, you want the
Subjective vertical, or do you want the Lopsia? Stand by, Bob. Space Lab Marshall, Bob, they're so happy with the data they've got on the first two runs, they would really like to have a third one.
Okay, we'll start off with the helmet on again, correct?
Now with the helmet off and beginning with a balance and a calibration.
Right.
Start off with a center, balance, center, right, center, left, center, up, center, down, center. Okay, we'll start with yaw. Okay, this is threshold. Okay, we've got to roll. Okay, threshold. Okay, now we'll go to Z. Nothing. All right, now we're going to stick. Eyes open. Bye-bye. Okay, threshold.
Okay, eyes closed and pitch.
Okay, eyes closed and yaw.
Okay. Yeah, balance
Let's calibrate.
center.
Center. Right. Center. Left. Center. Up. Center. Down. Center.
Okay, we'll put the helmet back on.
proceed with
yaw oscillopsia.
Once again, well, he did already twice.
X, now we go to Z. Now we go to pitch.
Okay, now we go to pitch
With eyes closed. Now we go to yaw with eyes closed.
Okay, any reports? Oh. Okay, essentially no oscillopsia with the helmet.
Okay, give you one more time. A balance setter.
Center,
Calibrate.
center, right, center, left, up, down, center.
Okay, POCC, we're now going to proceed with the subjective vertical.
That's fine, Bob, and we'll be looking for your vertical cues.
Say again?
And we'd like you to begin with a calibrate. Calibrate cross only.
Okay. Okay.
Center, center, right, center, left, center, up, center, down, center. How was that shot?
That's fine, Bob, and now you can go to mode 3 and begin.
Okay.
Space Flight Marshal, be advised, LOS in 1 minute.
I understand, but understand you don't need email.
That's affirmed, we do not need EMIR. And we did not hear the mark, Bob.
Again?
Please repeat this with the mark, if you would. We missed the mark.
The mark for what?
Mark for the vertical, Bob.
Blue. Alright,
Yeah. And before we go over the hill, Bob, we'd like the electrodes cleaned with alcohol wipes. Alcohol wipes, please.
plan on using it again.
That's affirmed.
do some real-time TV, TV 26, I believe. Has the BFI recorder thing been closed down? Yes, it has. Yes, okay.
Space Lab Marshall, AOS through TDRS for 48 minutes.
Marshall, loud and clear.
Okay, Ulf, for either you or Bob, whoever's got a minute, we've got the remainder of the PCAP changes to chat about during some time during this pass.
Okay. I'd like to ask one question in this context. As you might know, the MSDR is back online, and what is now the idea to grow? I'm talking about the mirror heating facility, which we got back, and what will we do with it?
Well, first of all, everybody's really happy about that, and they're working on a revised plan, and if you'll stand by for a minute, I'll check on their status. Space Lab Marshall, for Ulf, just a reminder, we've got ballistic cardiography coming up at 1500, and we'll be looking for real-time TV supported by TV 14.
Roger, TV is all set up, Chuck.
Okay, that's fine.
And the TV is at 15 plus 3-4. Okay. I think rather than go over the PCAP changes now, Bob, if we can have a little time after you're finished with 22, we may have incorporated the revised mirror heating furnace activities into it, and we won't have to do it twice.
Okay. One question, Chuck. I thought I heard you say this morning earlier we were going to do 2 people on ballistic cardiography this afternoon.
Say again your question, Bob.
Going to do 2 subjects on 28.
Negative. My PCAP shows only 1, and I'll, if you want, I'll double check on that.
That's okay. I thought I'd heard something about that. That's all. And it would have come from you, so if it didn't, I must have been mistaken.
14 at LOS or 14 at AOS?
Bob, I wonder if you could give us a quick status on how 22 went.
Well, I hate to sound too optimistic, but 22 seems to be going just great.
That's good to hear, and the PI copies. Answer to your question about ballistic cardiography, Bob. Evidently, the shorthand method we used to write the RR was a little confusing, and you're absolutely correct. The 028 PI would appreciate ballistic cardiography on both subjects.
Do we have the time? I don't know that we have the time to do it, though. That's one thing I was wondering about.
Okay, we'll smoke that over down here and get back with you on that one.
We got this CPAC one coming up very shortly after I finish with Ulf here. And then I've got a couple hours, but at that point, there's that CPAC comes up at 1600.
That's affirm, and I've got some changes for you when we get around to updating the PCAP. You can just write them in the PCAP. We could do that now if you're done.
I'll do that. Since I'm done 22, I'll do that while Ulf is putting on his sensors.
Okay, standing by.
Standing by.
Okay. Going to hour 16 for that CPAC run. This is going to be a change to an airglow experiment, which is model number 9er.
Okay, copy that.
The subordinate timeline is Sierra 02 Charlie 00.
Okay. Okay, will that have the correct GMT and everything in it for T0?
That's affirmed. The T0 is still 23 minutes.
Copy that. The same T0 as the old one.
That's affirmed. And the exception monitoring subordinate timeline is Sierra 02 Echo 05.
Okay, copy that.
And they would like PCF 61 equals 7.0.
Okay, 61 equals 7.0.
That's affirmed. And just a reminder, Bob, you guys have been watching for a DEP ready yes, and cycling the IU DEP switch. They want you to continue that activity for this run. Also, there will be...
that... Go ahead.
Yeah, you can also expect an MPD firing during this run, and there will be some MTV activity for which you should have a message number 30 Alpha.
I guess I'm not aware. That's an old, must be an old one, huh?
Yeah, that's an old one, Bob.
We'll go see if we can find it.
Okay, I've got it here in front of me if you can't. Space Lab Marshal for Bob.
Okay, we got you again.
Okay, just wanted to know whether the power switches got turned off on 201 in the rack unit.
I should be, yeah. Stand by. Let me take a look. Power's off. Yeah, they're off. Any reason to think they're on?
No, I guess they were concerned about it before and just wanted to double check.
All right. Okay, we're ready with ballistocardiography whenever you guys, we're sort of waiting for you guys on the TV, I guess, more than anything else at the moment on the ballisto.
Okay, stand by.
We can do that when you're ready for TV, or we can talk some more about the CPAC run as you like.
Okay, I think the only other thing we need to do with the CPAC is if you didn't find the message 30A, we could go through those steps.
First of all, is it a manual or a auto MTV?
It's a manual.
Chuck, this is Ulf.
Go ahead.
Okay, I asked you the question, what is the idea to, in respect to 330? Because you gave me 10 minutes time to do it, and I think that is not even enough to set it up. And you promised you would come back on that.
Yeah, that if you look at the next page, Ulf, you've got till 1825. Got lots of time. And we've got good real-time TV. We're looking at Ulf with your backpack on, hanging on the handrail.
Okay, a miracle of miracles, I just found message 30 Alpha. Okay, if you like... Go ahead and run 28 now. TOCC. Marshal Ops this is Space Lab.
Go ahead, Ulf.
I'm ready for 28. Whenever you are.
Okay, we're ready.
We're going. Okay, let's go then. Mark, hold your breath for 30 seconds. Mark. Mark. My mark, 15 seconds of throttle Valsalva. Mark. A pause for a, let's fix. On my mark, 30 seconds of normal breathing. Marshal Ops, which camera do you want to use? 2 or 1?
Gonna use 2, Ulf.
Okay, then I'll turn that way.
Space Lab Marshal, no response necessary. We're going to put some patches into the experiment computer that will help experiment 2 and 8 with the Route 21 problem. You may get a Route 21 skip message. You can ignore it. And for Ulf, you look great. And we're looking at Bob standing, floating right next to you, and it's a perfect picture. Hi to you.
Okay, on my mark, you're going to hold your breath for 15 seconds. Mark. My mark, 15 seconds of relaxed breathing. Mark. My mark, 15 seconds of isometrics with your ankles crossed, pulling. Mark. My mark, 30 seconds of crouched, breathe, holding your breath, crouched. Okay, that's it.
Space Lab Marshal, that was a good show, both from the science and the PAO.
Thank you. Good. Now we got the start.
Space Lab, this is XO28.
Oh.
Okay, we would like to have you stabilized as much as possible, and if you can stretch your legs during breath holding, it's very important, if you can, of course. And another thing, we would like to know if you have reached the desired heart rate, more than 120.
We do not know that. To make one comment on that, I think to stabilize, well, that's a good idea, but there's no difference in comparison to floating as we did right now. POCC with regard to what we were talking about before, whether or not we were having two subjects or not, we did that so far ahead that if that still is your request, we could probably fit that in right now.
That's affirmative, Bob.
Hey, we'll give us a few minutes to change around here, and we'll try that.
Okay, and we're so happy with the real-time TV, we're going to let you keep it up there until we go LOS, which will be in about another 20 minutes.
Okay. Keep those cards and letters coming.
Oh, they are.
Space Lab, this is XO28.
Stand by.
Columbia, Houston on air to ground 1.
Confirm.
Columbia, Houston on air to ground 1.
Houston, this is Columbia on air to ground 1. Radio check, over.
Roger, John, you're loud and clear. We couldn't hear you over Ascension. We have a couple messages here for you before we leave the shift, and I'd like to pass them on to you.
Okay, go ahead.
Okay, the first one is tank set 4, 5 are now empty, so we can now go ahead and deactivate those heaters.
Okay, wait a second. Okay, the heaters are off in 4, 5.
Okay, we copy, and the next one is a change to your future option, the maneuver that you have selected for 1612.
Let's go ahead.
Okay, we'd like to define a body vector of 5, and we'd like to define that one as pitch of 90, yaw of 350, and that'll give you an LVLH roll of plus 10 degrees. Everything else stays the same.
Okay, can you see what I'm doing here? I'll change it right now.
Roger, we'll look.
What you want, over? 290 off 350 and hold con of 0.
That's firm.
Okay.
Okay, John, we're happy with the configuration, and we're signing off here to the Orbit 1 shift. Brian and Fish will be coming on, and just enjoy talking to you and have a good lunch. Next UHF pass will be Guam at 1605.
And Space Lab for Ulf, we'd like to hear your instructions if you don't mind pressing your push to talk.
Okay. We are done with the first part and we come to the physical exercise. Hey, Chuck, is Trudy still around?
Say again? Oh, TV is still on, Ulf.
She can see how Bob can work.
We're very impressed.
So I am. Okay, Bob. Next thing is 15 seconds breath holding on my mark. Mark. Okay, next thing on my mark is 15 second relaxed breathing. Mark. And next thing is 15 seconds isometrics, cross angles. On my mark. Mark. And the last thing is 30 seconds crouched hold breath. Mark. Okay, that's it. Okay, marshal ops for the 28 people. Bob's heart rate was certainly above 90, I would guess around 100. The problem with this exercise is it stresses a lot the muscles, but only a few of them, and doesn't really so much load the cardiovascular system.
We copy that, Ulf, and thank you very much. We expect to see that on Wide World of Sports one of these days.
Space Lab XO28. Space Lab, this is XO28.
Okay, go ahead.
We just want to thank you very much for your strong engagement in the performance.
Yeah, welcome. And once again, it is really no difference whether you move slowly around in the module or whether you try to stabilize. I think if you really want to stabilize in respect to spacelab coordinates, you cause more artificial accelerations than if you just let it go.
We realized that while watching it too thoroughly. Thank you.
POCC, we just got a memory management 06. I don't know what you guys are doing down there.
We see it, Bob. We'll work it.
So we have again a row 14 problem here. Row skip 14 at 7 hours 35 minutes 39 seconds.
Roger, we see that. We're about 2 minutes from LOS, and a reminder, Bob, that for your next AEPI run, you've got a message number 93 Alpha with some instructions for you. We'll see you back again at 16:05. And Spacelab, the row skip 14 message you had was from was okay. We fixed it on the ground, and you can ignore it.
Thank you.
You're talking about Ulf's AEPI run at 1610?
That's affirmed. That's Ulf's. You've already got yours for CPAC, our problem. Thank you.
Okay, I don't think we have that message down here.
We copy that. Space Lab Marshall through Guam for 5 minutes.
Roger, got one small problem. The timeline that loaded this mile number 9 came up with a T033601,000, which of course isn't really working quite right.
Okay, stand by, Bob.
But it has started now. I don't know whether it's running or not. Get back with me and tell me whether you want to abort this and do it without timeline.
Bob, we'd like you to opt the ROW and the DEP and then run.
Twelfth, we have a DEP 05 error message. Time is 338, 8 hours, 6 minutes, 18 seconds.
Copy that, Off.
The ROW and the DEP are both opt, Marshall.
Roger. Space Lab Marshall, the DEP 05 message is normal. You can ignore that.
I think it refers to ice, so we forget it then.
Affirm. Space Lab for Bob, do you have a DEP ready? Yes?
That's right, we got a DEP ready, yes, but the T0, stand by a minute. The T0 was about 336 days instead of 338 days.
Copy.
I got it, I was 30 seconds. I have a message 30 seconds to T0 already. I'm not sure what it's doing. I wasn't talking to you guys. I just dump it and do it without supporting the timeline.
Bob, just to confirm, the STL you're counting is Sierra 02 Charlie 00?
Sierra 02 Charlie 00. Say 00 or 02?
02.
Oh, that's the problem. You want to start all over again? And now 60 seconds to off.
Okay, Bob, that's affirmative. We'd like you to restart with the Sierra 02 Charlie 00 and keep the same FO of 23 minutes, same T0 of 23 minutes.
Okay, I understand. Sierra 0 Charlie 02.
Negative. Sierra 02 Charlie 00.
What's the last number, 0 or 2?
0.
That's what I just started, and that's what gave me the 336 days.
Roger.
Say again, do you want me to restart or not, Chuck?
Stand by, Bob. We're looking at it.
Okay, the timeline I called was Sierra 02 Charlie 00.
That's correct. We think that it had the wrong time in it, and stand by. Yeah, Bob, we'd like you to use the checklist-4 manual ops procedure with the same T0 as the PCAP. Space Lab Marshall through TDRS for 49 minutes.
Okay, we're with you.
Okay, Bob, we apologize for the mix-up in communications on the CPAC run. We hope you straighten it out on your own.
Owes me one.
Say again?
And when we redid it without the subordinate timeline, that way we got, I had to describe a mixed result. What happened was everything ran fine, except it would not accept my PCF change. I don't know why. We got data management 02s each time we tried to do that.
Copy.
And just wouldn't accept it, so we ran with a 61 equal to 1.0. Whether it's for that reason or not, I'm not sure. The MTV picture we got, I wouldn't really describe as a picture so much as just an occasion you could see the flash light up when the beam went off. But the MPD obviously did fire. Just that there was no image, no real image on the screen.
Copy that, Bob, and it sounds like the back room's pleased. Yeah, we can hear him clapping all the way up here.
Marshal Ops, this is PS1.
Go ahead.
Okay, Chuck, I got camera irresponsive message for API, and I started over from scratch. It lost a few minutes, but I got a marvelous picture finally showing the limp.
Copy. And Ulf, we're wondering how the focus looked on the screen.
So what I'm saying is not really much, but it is good quality.
Okay, thank you. Space Lab for Bob, we'd like to know if you used the MTV to look at the beam and if you had a COL of 0. Space Lab Marshall, looks like we may be back with you. Space Lab Marshall, AOS, we think through TDRS and wonder how you copy, Bob or Ulf.
Marshall, loud and clear.
Okay, we had one question for Bob, if he's got a minute to answer it.
I may have been in different, we were in different attitudes, matter of fact. That's probably why. But this time I saw nothing except the whole field would occasionally just illuminate. As I say, it was no real image, just as clear as there was a lot of light around.
Copy that.
So I didn't see a particular spot or a jet or anything like that, just the general field illuminated. Both John and Ulf saw it out the windows.
Marshal Ops, one comment to that. It is probably impossible to follow the beam because that's not a beam, it is a flash. Marshal Ops, the Space Lab, how do you read?
Loud and clear, Ulf.
Chuck, just for the record, because I had trouble to get happy going, I switched the video recorder, the analog video recorder off for a little while until the signal was there, and then turned it on. So don't be surprised if you don't see the numbers you expect.
Okay, fine. And just a note for the next 40 minutes or so, we'd like you guys to get some lunch if you're not doing that already. I think that's pretty important. You've got a 101 run to do, Ulf, and we don't want you to begin that until about 16:45 or 16:50. No earlier than that, but you've got plenty of time to do it later if you'd like. Also for Bob, we've got a 102 FO2A activity scheduled, and that should be preceded by a TV-16 setup. Again, we'd like you to get some lunch, and we got considerable time downstream as long as Ulf gets to start the 3:30 run at 17 plus 50. And you've got 37 minutes of tape left on VTR-1.
Okay, well, we've been munching sunflower seeds up here all morning. We're doing pretty well.
Happy to hear that.
One question to the 101, Chuck. Is it possible that we knock the orbiter synchronization off again?
Yeah, that's going to be enabled by ground command at 16:35 or so, Ulf, and that's why we wanted you to wait a little bit before you did the plant selection. We'll also have the PI enabled on the loop, and we'd like you to use the left rotor camera for the selection.
Sounds great to me. I thought I select from the right rotor. No, left rotor, that's correct. Okay, I'm looking forward.
You want to start this at 16:35 or 40 at 16:48 already.
Yeah, you're right. We were watching our PCAP here, and we had a little late acquisition. That's why we're a little behind on figuring out where we were.
I mean, we lost our lunch, huh?
No, eat your lunch.
Marshal Ops, this is PS1.
Marshal Ops, go ahead, Wolf.
Okay, I'm basically ready for 101. I wonder whether we would get real-time television, downlink.
Stand by, and I will engage the PI of 101. And Wolf is negative on the real-time downlink.
Okay, then I will do it on my own as good as possible.
Spacecraft, this is X-101. Com check, do you copy? Spacecraft, this is Experiment 101. Com check, do you copy?
Marshal Ops, Space Lab.
Okay, Wolf, we brought the PI of 101 on the loop. So if you have some information...
Okay. And be aware that the orbiter synchronization seems to be on right now.
We'll check.
Marshal Ops.
Go ahead, Ulf.
Okay, with the system as it is now, I will have trouble to select from the right rotor because I cannot see anything on the video monitor. So I request that we configure the video system such that there's no orbiter synchronization in here.
Okay, Ulf, stand by. We're still checking whether that sync is on or off. Over.
Okay. Hey, John? Well, I think you got from the conversation that on that little video system we have here to select the sunflowers, there's nothing else, and it only works if we knock off the orbiter synchronization.
And Space Lab, this is Marshal Ops.
Wait a minute, they are working on that. Yeah, Wolf?
Yes, Ulf. It's supposed to be off, but we did not get the telemetry down whether it is really off. Over.
Okay, Wolf, I'm back with you. I missed what you said because John Young is talking to me.
Understand, Ulf. I just was saying that it was supposed to be off. We, however, did not get a confirmation. Over.
Yeah, I bet it's on, but I'm waiting here.
Space Lab, this is Experiment 101. Do you copy? Space, this is Experiment 101. Do you copy? Space Lab, this is Experiment 101. Copy. Space Lab, this is Experiment 101. Do you copy?
The mountains, it's fantastic. Spectacular.
Ulf, this is Marshal Ops. We have a problem getting the 101 online, so I have to relay his questions. His first question was whether you can tell him which rotors you have stopped and how you're going to do the plan selection.
According to procedure, I stopped the right rotor.
Is that camera sufficient quality to be able to do the plan selection?
Negative, that's impossible. There's only snow on the video monitor.
What about using the left rotor camera for the right rotor selection?
You can try.
Okay.
I'll come back with you.
And also, Ulf, be advised that at the last part of this pass, and that's around 5 minutes from now, we need to uplink sometimes for the MHF procedure.
Okay, why don't we do that right now?
Or is Bob there to copy?
I can copy that.
Okay. Procedure F400 for 321 Alpha -24. Steps 5.1.
Wait a minute, Woo-Woo. I have to pick up a pencil and something to write.
Okay. And
you should always... Little moment.
Space Lab, this is Experiment 101. Comm check. Do you copy?
Okay, Woo-Woo, go ahead.
Okay, Ulf, step 5.1 until 5.12 of the normal MHF setup, starting at 17 hours 40.
Okay. Mirror heating facility, 5.5 till 5.12.
Negative 5.1.
Okay, and then?
And for the time being, the only important thing there is that at 18.15, you have to do the pre-inspection resume of 321. And that's all for the time being, over.
And once again, that is for today, is that correct?
That is for today, and on the next pass we come back on it, and I would like to give you over to 101 again, or do that experiment. I will relay the messages of 101.
Okay, fine. Hey, John, once again, I'm back at the window and see now a lot of mountains with snow. Is that still Africa? Ah, that's fantastic. Yeah, I tell you what, these are the Alps. That is the Mediterranean on the south side. And northern Italy. Can you take a shot? There's the Po River. That's right underneath us now. The Garda Lake, oh gee, is it pretty? Now we are running into Bavaria. Jesus Christ.
Space Lab in heaven for Ulf. And Space Lab, this is Marshal Ops for Ulf. Space Lab, this is Marshal Ops for Ulf.
No, it's really true. That's not so difficult to find the cities.
And Space Lab, this is Marshal Ops for Ulf.
Go ahead, Marshal Ops.
Yes, Ulf, the following information from 101. The right rotor camera cannot work without external sync, and therefore will not work. The left rotor camera, however, should work. Over.
Yeah, that sounds great. I will stop the left rotor and use the left rotor camera for the selection then.
Okay, Ulf, and in the malfunction 101.18 is described how to perform this.
Okay, thank you. By the way, Ubo, just for your information, we have just passed the Alps. It's breathtaking. There's snow all over Europe, northern Europe.
Thanks for the information, Ulf.
Seems to be a good winter for skiing.
We'll get there.
Space Lab, this is 101 for a comm check. Do you copy?
Camera is working and we have a nice video image.
Space Lab, this is experiment 101 for comm check. Do you copy?
101, this is Space Lab reading you loud and clear, and I'm in the process of using the left rotor camera to do a selection from the right side.
Very good.
I have the first module in the left rotor here, and for your information, it's module 5, which is mated with pot 32, and that one looks already pretty good. That goes into the upper left position of the dark box.
And Space Lab, Marshall Ops 1 minute from LOS.
Copy. Module 2 was a loser, and Module 3 is also not too good. The plans hang on the ground here. Marshall Ops, are you still there?
We're still there, Ulf, and for Bob, verify that he has message 45 for 101 FO2A.
Okay, I have another acceptable plan here.
now.
Space Lab Marshal through Guam for about 5.5 minutes.
Okay, Marshal, loud and clear. We completed the plant selection 101 and we used the left rotor.
Copy.
You confirm with 201, with 101 that the right rotor should be switched off here? That's what I did.
Stand by. And Ulf, your question about the 101 right rotor, the answer to that is correct. You should have switched it off.
That's what I did, and I'd like to come back to the mirror heating facility. I got from Bubo the instruction to execute a couple of steps in the procedure. And I think the time given was 18:15, but it is not clear to me whether it's Bob or whether it's me who's supposed to do that.
Okay, and Wilbo's right here to talk to you about that.
Yes, Ulf, I will give you the following times. It is start with step 5.1 at 17 plus 40, and go through 5.12, 1-2. That's the setup, the sample.
Okay, and is that me or is that Bob?
That is you, Ulf.
Okay, so I can start right now, right?
17, yeah, right. But I give you two other times, which you need to know now. One is that you have to do the inspection and resume before, or at, actually, 18:30, 30. And the heat under crew is at 20 hours and 10. And I have one correction for the resume after inspection should be at 18 plus 15, over.
Okay, well, I moved over to the VCAP, and I'd like you to repeat that whole thing that I've pen and ink it into the PCAP.
Roger. And Ulf, we have 35 seconds to LOS, over.
Yeah, could you quickly repeat the times?
17 plus 40, set up sample. 18 plus 15. Crew resume after sample inspection. Over.
Pat?
And the rest of the information we get you at the next path.
Okay, got that.
Yes.
Space Lab Marshal Ops, AOS Tidris for 49 minutes.
Oh, that sounds great. Marshal Ops, this is Space Lab.
Low off.
Marshal Ops? Oh, you read.
Loud and clear off.
Okay, Chuck, what do you want me to do for Jan Freiburg?
We wonder where you are in the procedure at this point.
Are you talking about Jan or about the MHF?
I'm talking about Jan. 3:30?
Yeah, I got 10 minutes time and I didn't get any more specific information what to do. That's why I'm standing by. What do you want me to do? Set it up for what?
Stand by. Space Lab Marshal for Ulf. Ulf, we're hoping that you'll be continuing on with 3:30, and we've got John Pade here on the line ready to help you with 3:30. And in general, what we're doing throughout here is letting you continue with 3:30. And as you need to break off and work on 3:21 at the appropriate times, then that's what we'd like you to do, and we'll try and keep you informed on when those times are.
Okay, I might be ahead of time. We did the sample pre-inspection, and the MHF is really in great shape. It works perfectly. There's only one thing we get from time to time, a VHS fault, and the fault ID is 007.
Copy that. Okay, Ulf, no action necessary on that one. That sure sounds good.
Okay, and we right now an SIU data fault light on. I hope that is not too serious. System is at least working.
Yeah, we concur, Ulf.
POCC Space Lab.
Go ahead, Bob.
Yeah, I hate to be the one to suggest this, but in looking over the flight plan, I see plenty of time for me to do the FO2A, but I really don't see any time for Ulf to do that with me.
Yeah, we're looking at what we might juggle around for you, Bob.
Maybe we could try it tomorrow.
Yeah, that's one possibility we're looking at.
Space Lab, 300 PI here in the form of John Padday. Are you hearing me? The aim of the experiment, I'm sure, is self-evident, but Jan just wants you to measure, not record, on the camera, the eigenfrequencies at steps 4-1, 6-3, 6-6, and 7-8 for the spherical cavity, and for the annual container at the steps indicated in the procedures, but I'll read them out if you haven't got them.
John, that is too much information at a time.
Okay. Ulf, the best thing then is to search oscillation frequency with the spherical cavity in position. Is this in the FPM?
Okay, we have the end plates already set, but I'm standing by to find out what container you want me to do first. And you are telling now you want me to do the sphere. Is that correct?
If that is in the FPM, yes.
I'm just taking a look to it. Stand by. Okay, John, we got the sphere.
Okay.
Do you know by heart whether that is running with viewing aid or without?
Repeat, please. With viewing aid.
Okay, we'll take that out then.
Space Lab Marshal, with a brief note, we're going to be maneuvering to a solar attitude here in a few minutes in order to give experiment 008 some data, and number 8, experiment 8, will also be commanding at that time.
Okay, roger. Oh, John, that doesn't hurt us. You can do whatever you like.
Okay. Without any rotation, could you search for the first oscillation frequency? I should suggest starting at 0.7.
Certainly, we'll do that. Starting at 0.7, search for resonance.
It would help if you could describe what you see.
Okay, we'll do that, but first we have to set it up to him.
How's it going, Ulf?
Fine, we are almost there.
Ulf, it looks as though we're approaching Luigi's 328B, which I believe starts quite soon. This experiment is obviously taking a lot longer than we expected, and it seems to me fair that we should perhaps close it down and try finding another spot if possible. Otherwise, 328B will not start on time and may be compromised.
John, that's what I thought from the beginning. 10 minutes, that's the time you need to set it up, and then there's not much time left to run the experiment.
I'm very sorry, Ulf. I didn't realize. I rang up Jan, and he said 25 minutes would do the experiment. I suggest we close off and get down to 328B. I've got Luigi here, right by me here. Thanks very much, Ulf. I'm sure what you've done is well appreciated.
Space Lab 328.
Hello, Luigi. Buona nuit.
Hello, Ulf. How are you? Good work. Wonderful guy.
Oh, yeah, you bet.
Did you receive my modification for step 2-1?
I have to look through a whole pile of messages we got. We'll tell you in a minute.
In the meantime, Space Lab for Bob.
To go.
Bob, for your 22 run coming up at 19:03, we have a GMT time change for you.
Okay, go ahead.
New GMT is 11 hours, 15 minutes, 30 seconds, and that includes the 30-second early start on this one.
Okay, I understand. 11, 15, 30.
That's firm, and that's replanning request 22003, which may be on a tags message, but you don't need to know that just as long as you get the GMT right.
Okay.
Also, the RA and the deck are now plus or minus 0.5 for both instead of 2.0.
Okay.
Also, Bob, while we have a minute, one of these times we'd like to get from you a definition of the two outer points of the targets that you used on the aft end cone for the oscillopsia. We're going to call back to the folks in Huntsville at the PCTC and ask if they can accurately determine what the included angle is using those points, if we can find them on our mock-up, and measuring from where you were standing, which we assume is just aft of the center aisle bracket.
Yeah, it's just after the center aisle cage, and it's the same ones we always use. It's essentially the edges of the cylindrical, of the circular end of the end cone. I think the 102 people know those already, because Byron gave us those positions.
Okay, they're the same. Use those same ones for the oscillopsia then. Thanks a lot.
That's affirmed.
Luigi,
Yes, Ulf. Space Lab 328. Space Lab 300 328.
PI 328, this is Space Lab. We are looking to find the update for your procedure.
Space Lab 328.
Luigi, this is Space Lab. How do you read?
I read you well. Can I give it to you by voice?
Sure.
Okay, so it's step 2-1. Can you read me?
Yeah, stand by. I'm looking into your step 2-1. A second.
Very.
Okay, step 2-1. Got
Okay.
that?
Okay, you correct the front plate position to 5-0.
It's done.
Then the speed to speed. I repeat, speed 0.22.
Say again, speed 328.
I'm sorry, no, speed is 0.22.
It is 0.22, got that?
Then reservoir position decimal point 385.
Decimal 385.
And then speed decimal 23.
Okay, reservoir position with speed decimal 23.
That's right.
Say again the speed for the front plate. It appears to me that you picked the smaller speed for the front plate.
You're right. You're right. The reservoir speed is 017, decimal 17. I'm correct.
017. Okay.
That's right. Now, Ulf, listen. There is also another point. You should omit step 3-1.
Okay, 3-1.
237.
237. Okay, the whole page.
Yes, and then step 5-1 to 5-7, the whole page.
Okay, 5-1 to 5-7.
And then finally omit 7-1 to 7-9. That is wherever there is the electric field.
7-1 to 7-9 is deleted.
Yes. Now, one more thing. When you use the Centi-Stokes 100, yes. Are you reading me?
Yes, loud and clear.
Okay, so you shake very vigorously the 100 Centi-Stokes. But if you don't see tracers, then you have to go back and use the 500 Centi-Stokes. Do you read me?
Okay.
Okay.
I understand you want me to shake the reservoir with the 100 Centi-Stokes.
Yes.
Okay, copy that.
Then at step 4-3, if you don't see the tracers, you have to stop and retrieve the 100 Centi-Stokes and use Unstow reservoir 5 Centi-Stokes.
Copy.
You know where this is stowed?
Yes, I do.
Okay.
That all, Luigi?
Yeah, that's all. And then you know the aim, the main aim is to establish the breach. Never mind if it's not perfectly cylindrical. We have had some troubles with the wetting.
Yeah, I talked to Byron, and Byron talked to me, and we all have the same problem.
Yes.
Whenever the contact angle comes close to 90 degrees, then things become very unstable.
That's right. Quite right. Excellent. Yeah. So Ulf, you use your judgment. You know, you go by hand, whatever you want.
Okay, I will try to do my
hopefully-
best for you.
Yeah. Hopefully, my new data will not have any problem with my new data.
Okay?
Okay. Should.
Okay, then let's go for it.
Space Lab 328. Space Lab 328. Space Lab 328. Space Lab, this is 328.
Fine, Richie.
Are you already with my setup or no?
You bet. We are working on yours.
Space Lab, this is 328. Space Lab, this is 328.
How do you read? Do you read me?
Yes, I do. What step are you at?
Have your reservoir installed on the end plate. Okay. That's not the right one. Right. Not yet. Left. This is there's one installed. This is Space Lab.
Space Lab, this is 328.
This is Space Lab. F1 question in magazines.
Yeah?
There is one magazine left at camera A. Does that mean that there is still sufficient film in this magazine, or is that by mistake?
No, that's sufficient film already.
And we use magazine 328B for camera Bravo. Is that all right?
That's all right.
Copy that. That already unpacked.
Space Lab, this is 328.
Okay, go ahead.
Before your LOS, I want to tell you that at step 8.3, you have also to modify the FP position to 50 and the reservoir position to 45. Do you read me?
You read 50 for the front plate and for the reservoir 45, is that correct?
Correct. This is at step 8.3, yeah?
3, yeah, 50 and 45.
Correct.
Space Lab, Marshal Ops for Bob. Bob, we're putting the finishing touches on a 33 troubleshooting procedure for you to perform sometime around the 2100 period. And in order to clear up that time for you, there's some 16 millimeter and 8 millimeter and 35 millimeter photography of material science that you might be able to take care of now to clear the way for the other activity at 2100.
Okay.
Also, we're 3 minutes from LOS.
Okay.
We'll see you at about 1921 through Auroral. Space Lab Marshal for OF.
Go ahead, Marshal.
OF, we need you to change the experiment number at the CCO to 328.
Okay, we'll do that for you immediately.
That's fine. Thanks a lot. We'll see you at Auroral.
Space Lab, Marshall Ops, AOS through Auroral for 6 minutes.
Okay.
Go ahead.
Ops, we have a little problem here with Luigi.
Say again your problem, Wolf. Space Lab, Houston, Air to Ground 1.
Hey, Houston.
Roger, Bob. I've got a note for you dealing with your SAL outer hatch lock procedure when you're ready to copy.
Okay, stand by. Okay, ready, copy.
Yeah, it probably isn't anything you need to write down in great detail, Bob. It's just that whenever the outer hatch is closed, we'd like to recommend that it be locked as per your Space Lab Ops checklist procedures on page 7-15. Over.
As far as I know, it always is. I don't know, think somebody got some concern?
We show it closed but not locked, Bob.
Don't understand that, because it's always latched. Unless they mean putting the solenoid pin back up into the latches. If you mean locked, maybe not locked, but it's always locked.
Stand by just a sec, Bob. Space Lab Houston. Bob, we're looking at the procedures, and we'll get back with you as soon as we have a more specific instruction for you.
Yeah, the only thing I can think of is perhaps they're talking about the engaging the solenoid, the actual lock pin that locks the latch, as opposed to just the latch that locks the outer cover down, which is what I call a lock.
Roger, Bob. What we want to have done is the lock, as you just described.
All right.
In Space Lab Houston, Air to Ground 1, I got a message for John.
Houston, go ahead.
Roger, John. We need to boil water through the fest so we can make it to the next water dump. We'd like you to go to panel L1, your rag controller out temp to high, please.
Okay, going to high on the outlet temperature.
Roger, thank you.
Got it.
step better.
Is it a movie or TV? We can each come prepared with some view graphs.
Space Lab Marshall through TDRS for 48 minutes.
We're with you. POCC, you might wonder about whether we need this tight deadband, which I assume you guys have put as a requirement on the MOCR. The 22 deadband that we're still in for the next hour or so when we're not using 22. We're just sitting here in daylight. You guys want to think about that?
Sure will.
Might be able to stay up here 11 days at this rate.
Marshall, this is PS1.
Read you loud and clear, Ulf, but we're about to go over the tail. We might be intermittent on the comm. Space Lab Marshall, looks like we've got an uplink back, for at least for a short time. Need to talk to Bob for a minute.
Go ahead.
Bob, CPAC tells us that they'll be 100% charged before too long, and they'd like you to turn off the battery charging at 20 hours straight up rather than 6 days even.
Okay, I'll make a little mark for that.
And Bob, if you would, can you give us the location of the cameras currently? We're a little confused after we did some real time there.
In TVC1?
Both of them, if you would.
Can't find it. But the ones at the TVC2s at the aft end looking forward, it's not turned on. And TVC1 is getting ready for TV3, looking down at the layout canister changeout.
Thank you, that's great. And Bob, in answer to your question on the deadband, we've talked it over with FAO. We are in the narrow deadband, and they claim that it's really no saving in gas to switch it at this point.
All right. Trying to help.
Appreciate the thought. Space Lab Marshal, looks like we've recovered the comm. Ulf, we need to let you know that you have until about 20 hours and 5 minutes to work on fluid physics, and we expect the MHF ops light to be flashing around then or perhaps a little earlier.